Hey guys, welcome back. We're going to start in on lesson 6 of our unit 5 workbook, which starts on page 28. So if you want to join me there, we will get going through it. Okay, so this lesson talks about solving the equation one chunk at a time. And I know we have solved some equations before, but now we're really moving into doing that full time with just hopefully looking at the equation. We start here with a think out loud. Michael says, hey, I thought of a number trick, but then I made it into an equation. Can you use my equation to find my starting number? Michael writes 50 minus 2x divided by 7 equals 6 on the board. That's his equation and his ending number. Jay says, okay, when we were thinking about these before, we would start with the last step and work backwards one step at a time. It looks like the last step was divide by 7. So he had this 50 minus 2x, divided it by 7 and got 6. Jay says, let's make it easier to look at, and then Jay covers part of the equation. So he covers that top half. Which reveals divide 7 equals 6. What divided by 7 gives us 6? Okay, so the 50 minus 2x that got you that you have covered equals 42, because that's 7 times 6, or 42 divided by 7 is 6. Lena writes 50 minus 2x equals 42 on the board. So that's our next equation. Jay says, nice. And before that, he subtracted 2x from 50. So the instructions must have been subtract the result from 50. Okay. Then we cover up the previous result, the 2x, which he did down here. And just look at that step. J covers up part of the equation. 50 minus what he covered up equals 42. So 50 minus what is 42? It's 8. So 2x equals 8. That means x must be 4. So you started with 4, Michael. Okay, so that's one way we can look through that. Algebraic habits of mind, seeking and using structure. Look at the bigger picture. Looking at the bigger picture can help you solve an equation, especially if the equation looks complicated. Once you find the last instruction, cover up the rest of the expression and find the value of what's hidden. Okay, so write a new equation for each step and solve for the variable. Okay, so here it looks like their last step was subtract. So think of 20 minus, and they covered this up, equals 2. So if I cover this up, 20 minus what is 2? That would be 18. 20 minus 18 is 2. So this value here must be 18. Okay, so then I cover the P up. 3 times what is 18? And that would be 6. Okay, here we'll cover this. The subtraction was the last thing that they did, so cover that part up. So 20 minus what is 2? Again, that's 18. And cover up the A. Something plus 10 is 18. That would be 8. Okay, here we're going to cover up this portion. 20 minus something would be 2. Again, that's 18. Okay, then we're going to cover this up. What number divided by 2 is 18? So x would be 36. So 36 divided by 2 gives you that 18. Okay, here we'll cover up this portion, which we'll write down. We covered up 30 minus n. So 20 minus something is 2. That's 18. Okay, then we cover this up. 30 minus something is 18. So that would be 30 minus 12, and n would be 12. Okay, so this is one way of working through these problems. Use the same method to solve, writing the new equation for each step. Okay, so here we've got 30. We're going to cover this part up. 30 divided by what is 3? That would be 10. And then what number plus 1 is 10? So that would be 9 plus 1 is 10. Okay, here we're going to cover up the 5y. So 30 divided by blank is 3. So that must be 5y equals 10. And then 5 times what number is 10? That's 2. Okay, in problems 5 and 6, you have the same structure. Write 2 more problems that have the same structure. Just write the problems just write the problems, you don't have to solve them. So the same structure means like you're dividing over here to equal a single number. So you can have anything and we can really just make them up because we don't have to solve them, but we've got 30 on top and 3 equals, so 30 divided by something equals 3. 30 divided by something equals 3. It looks like they just wrote things on the bottom. So let's say 2w minus 5. And here we can say z plus 3 or negative z plus 3. Doesn't matter. Okay, we've got the same type of structure there. Okay, coming over to number 8. Money thought of a number, added 4, divide that entire result by 2 and got 14 as her final result. Write an expression for the trick. Okay, so we're not going to write in her result. We're just going to write the expression. So a number, added 4, divided that entire result by 2. And that's it. Jay created an equation from this problem that includes Armani's final result. Use it to find her starting number. Okay, so this is the last step, so we're going to cover this part up. What number divided by 2 is 14? And that would be 28. So 28 equals n plus 4. Then what number plus 4 gives you the 28? That would be 24. So her original number was 24. Raja thought of a number, multiplied by 3, added 10, doubled the result, and got 62. Create and solve an equation to determine his starting number. Okay, so write the equation. So thought of a number, multiplied by 3, added 10, and then doubled that result. So doubled that whole thing and got 62. Okay, use your equation to find Raja's starting number. Okay, so 2, 3n plus 10 equals 62. Okay, so this multiplied by 2 is the last step. So what number times 2 is 62? That would be 31. So 3n plus 10 equals 31. Okay, we added 10 last. So what number plus 10 is 31? That would be 21 equals 3n. And then 3 times what is 21? That would be 7. Maria thought of a number, added 6, divided by 2, subtracted 4, and got 0. Create and solve an equation to determine her starting number. So she thought of a number, added 6, divided by 2, and then from that, she subtracted 4 and got 0. Okay, so we'll cover this up. What number minus 4 is 0? That would be 4. So n plus 6 over 2. Then the last thing was divide by 2. So what number divided by 2 is 4? That is 8 divided by 2 is 4. So that's n plus 6. Then what number plus 6 is 8? That would be 2. So Maria's first number was 2. Okay, algebraic habits of mind, seeking and using structure. There are many good ways to think about solving equations. You can compare them to mobiles. The two sides must stay balanced, or you can cover up a complicated chunk of an expression to see if the surrounding information shows what the chunk must equal. You can even switch back and forth using both strategies as long as you use logic to make sure that each step makes sense. Okay, so here on number 11, what could star, water, and hexagon be if all variables represent different numbers? Okay, so let's see here. These three are the same, equals a star. Water times this equals a star, and this plus this equals that. So if let's just start with a number maybe, okay? They're all different numbers. So let's just start here with 1. So 1 plus 1 is 2. Is 2. This is 2. That's a 1. Well, this would have to be a 2, and that can't be because they all have to be different numbers. Okay. Let's see if this was a 2. So 2 plus 2, 2, 2. 2 plus 2 is 4. So this would have to be 4, and this would have to be 2. I still can't do that. So let's make these a 3. 3, 3. 3 plus 3 is 6. This is 3. Sorry, that's 6. This is 3. So 2 times 3 is 6. So I think we got 6, 2, and 3. So this is 2, 2, 2, and 6. Okay, so that one worked out. Just a little bit of trial and error there. Okay, what could triangle, circle, star be if all the variables are different? Okay, well, we have some things here. I know, okay, let's look at this. A circle and a triangle actually equal a star times a star times a star. Okay. And a star plus a triangle equals a circle. So I have a star and a triangle. We could use some scratch paper here. Maybe work some of this out. Maybe in some mobiles or some equations here. So we have a star plus a triangle equals a circle, which might look something like this. A star plus a triangle equals a circle. Now, it's hard to do the multiplication in this. I meant to use letters here. That's a T and a C. And an S times a circle equals a S plus T plus C. So I know S and T equals a C. So instead of writing this, I could write a C. C plus C equals S times C. So be careful with that. And then here I have an S times S times S equals a t plus c. And we saw that a t, oh, we had a t and a c there, was a bunch of stars. Okay, so this is S times C is 2 C's. So I don't know, maybe we just start with a number somewhere. Let's see here. Let's go back to this original. S times C equals S plus T plus C. Whoop, I'm sorry, I'm not even on the page here. And what if we use this, that T and C, so this equals S times S times S. So S times C equals S plus S times S times S. Well, that's a lot of stars. Okay, so a lot of stars there. Okay, so I know a circle equals a star plus a triangle. So C is star plus a triangle. Okay, I can. Let's just, okay, let's go back and let's just start plugging in some numbers here. Let's let a star equal 1. So that's a 1, 1, 1. 1 times 1 times 1 is 1. So one of these would have to be a 0 and a negative. None of them are negative, so we can't do that. Okay, what if a star was 2? So 2, 2, 2. 2, 2, 2. So 2 times 2 is 4 times 2 is 8. Okay, I've got some options there then. So that could be, if this is 8, this could be 5 and 3, maybe 5 and 3. I was thinking 4 and 4, but they can't be the same. I was thinking 2 and 6, but I already have a 2. So let's see, this is 3 and this is 5 and 3. This is 5 and 3. Well, 2 plus 5 does not equal 3. So maybe I got to switch those to a 3 and a 5. So 2 plus 3 is 5. So I got to switch these. So circle maybe 5, triangle 3. Okay, 2 times 5 is 10. And then this equals 10. And then this equals 8, which is that. So we got 2, 5, and 3. Okay, so a little bit difficult there. We could set up some equations and solve those out if we wanted to, but sometimes just guessing and checking is a bit easier. Okay, cover up the P plus 1, show your immediate steps as you solve these equations. Okay, so cover this up. 16 minus what is 11? That's 5. Okay, P plus 1. So some number plus 1 is 5. That's 4. Here we're going to cover up the A plus 3. So 25 divided by what is 5? That's 5. What number plus 3 is 5? And that would be 2. Okay, cover this up. 8 minus something is 3. That's 5. And then 10 divided by something is 5. 10 divided by 2 is 5. Okay, so solving some of those equations. And that actually ends it for this part of lesson 6 there. So you can begin thinking about doing your additional practice on page 31 and 32. There's 2 pages of it this time. And then if you have questions, feel free to reach out or ask me during class. We'll see you in the next one.